So let's consider a harmonic wave moving to the right. And so I want to have some sort of description of this wave. Okay, so there's y and there's x. And so as the wave is moving, I want to say what is y as a function of both x and t. So I want to know y is a function of both x and t. So at some point later, where is it? And so we think about it and we say, okay, so we got something like that. And so obviously that can be described as sine of y equals sine of x. Well, not exactly, because we have some amplitude. So it goes to plus a and minus a. So that allows us to have a bigger wave or a smaller wave by multiplying the a there. Okay, the other thing is we could have a wave with a long wavelength or a wave with a short wavelength. So we need something that multiplies times x. So we can have sine kx, and we call k the wave number. Okay, so it's just a number. It has units 1 over distance, and so that number basically tells us the how tightly spaced the waves are. Well, that's not the entire wave right there, because that just gives you the sine function. I want to say, how does it move? So we need time to be part of this. And so if it moves to the right, it's almost as if as time passes, we're looking at the original wave farther and farther to the left. So we could say this is a times sine kx minus something times t. Okay, now the something times t would be relate to how fast it's moving. Well, we already are used to using omega t to represent an angle. So this equation right here would be the equation for a harmonic wave that's moving to the right. So what would a harmonic wave moving to the left look like? Well, that would be y equals a sine kx plus omega t. So that's moving left, and the y equals a sine kx minus omega t is a wave moving to the right. Okay, when I was a student, this really confused me, because those signs, the plus means moving left and the minus means moving right. And when I was a student, I found that very confusing. Okay, so I like to point that out right here so that you don't get confused by it. Just point out this is why it's the way that it is. Okay, so why that is for the wave here, how high up, and so that's a sine kx minus omega t. K is the wave number, and omega is what we call the angular frequency. Okay. So, now how do these relate to some of the other properties that we want to know? So sine omega kx minus omega t. So what we want is that for our wave here, when we go through one complete cycle of x, we want that to be one wavelength. So in other words, when x equals lambda, then kx has to go through 2 pi. Okay, this is in radians. So you have to make sure your calculator is set in radians mode here. Okay, so kx, but x is lambda. So that means that k lambda is 2 pi. So 2 pi divided by lambda is k. So the wave number is 2 pi over lambda. Okay. Now, what about the other term? Well, when you've gone through one period, so when t is one period, then we want omega t, so that's going to be omega times period. We want that to equal 2 pi. And so that means that omega is 2 pi over period, or in other words, 2 pi times f. Okay, so the angular frequency is 2 pi times the actual frequency of the wave. And so we now have y equals a sine kx minus omega t. We know that k is 2 pi over lambda. This is the wave number. We have omega equals 2 pi times frequency. And so frequency is what you normally measure. 2 pi times that is what actually goes into the equation right here. And so you look at it and you realize that these numbers are not independent of each other. That in fact, we know that C is lambda times F, right? Okay. And so we look at it and say, well, wait a minute. So, that would be the same as 2 pi over 2 pi lambda f. Or in other words, this would be equal to lambda over 2 pi times 2 pi f. Or in other words, C is going to be equal to omega over k. So that's the relationship between these two properties. So we have the wave number, we have the angular frequency, and the relationship between the angular frequency and the wave number is angular frequency divided by wave number is going to equal the speed of the wave. And so that way we can interpret from this everything we need to know. Okay.